Hello and welcome to this repair tutorial, and today we're going to look at an A&R Cambridge A60 amplifier. If you sort of do a Google search, you'll find that there are hi-fi reviews dating back to about 1977. So this amplifier of course goes back quite a while, and I often use the term a classic British amplifier, and clearly, you know, when you look at the design and the build quality of this amplifier and also the audio that it produces, it truly is a classic. And I do enjoy working on these amplifiers, both repairing them and also servicing, restoring them back to their former glory. So if we look first of all at some of the specifications here, so RMS power output would be 40 watts, and this is times 2 into 8 ohm speaker loads. What you have is, and it was very common at this time, on the rear of the amplifier you have multiple sets of speaker contact. You have our switched and unswitched. So just to sort of clarify for anyone who's maybe not familiar with that term, what it simply means is that if you plug in the headphones jack socket and you're connected to the switched set of speaker terminals, then effectively it will just disable the speakers, and then of course when you remove the headphones jack, then it will reconnect and then your speakers reconnect. So that's the difference between the switched and unswitched, so just for clarification. And then frequency response, we're looking at 20 hertz to 20 kilohertz, and then total harmonic distortion is 0.2%, and input sensitivity for moving magnet input for direct connection for a turntable is 2 millivolts, and for all of the other, in terms of your line inputs, they're 100 millivolts. So that's quite low. But remember, you got to remember the time period this amplifier was sort of built. More modern day amplifiers, they've increased that, so it's more common now to sort of find 150 millivolts plus, but that's what you have. And then dimensions is 450 wide by 255 depth, and then 60 millimeter height. And not a heavy amplifier, so coming in at 5 kilograms. And then when you look at the front, you have your selection switch where you can go disc, so this is where you would connect your turntable. You can then select mono. Again, this is common of this time period. Switch between mono and then stereo. You also have a HF filter as well. So this is this filter push button that you have. And then of course then you can select your other inputs. So quite limited. You've got your sort of your tuner input in there as well, and then also your tape. And then on the front, very clean layout. So power on off switch, and then you have your volume control, bass, treble, and balance, and the only sort of last remaining thing is the headphone socket. So really, what was the issue with this amplifier? Well, it came in from the customer, and the customer had outlined that there was an issue with the failing of the secondary power supply fuses. So these are rated as fast blow, and they're 3.15 amp, and it was blowing these fuses on power up. But the amplifier had been worked on previously, and I understand from the owner that the 2 large electrolytic capacitors in the power supply had been replaced. But there was also some other sort of descriptions of issues where that when the amplifier powered up and the speakers was connected, you sort of got like a thud sound coming through the speakers. So that was something else which needed to be determined and then investigated. So what I show here is the different stages really of the repair. So the first one is to verify or to confirm why are these power supply fuses failing. So what you do is you connect up the dim bulb tester. So this is the current limiting device, and I could just power up the amplifier, and sure enough, straight away you got the bulb and it lit very, very brightly, indicating high current draw. The nice thing here is the secondary of the transformer just plugs onto the main board. So all you need to do, just depower the amp and then just unplug it, and then what I'm able to do then is to power up the amplifier. And what I'm verifying is the excess power draw coming from the transformer windings, or is it coming from the secondary? Now when you think about this is really a 2-stage operation. Now you also have an input power supply fuse as well, and we'll come back to that a little bit later on. But because the fuse on the secondary of the transformer were blowing, that's sort of indicating to you that the excess current draw is due to an issue on the amplifier board. Okay, so it could be the rectifiers, it may also be an issue maybe in the power supply stroke the output stage. It wouldn't normally indicate that there was an issue with the transformer primary side because the input power supply fuse is not blowing, but it's just really a stage approach. Because you can just unplug it, then I can just test that transformer out. So I'm just making sure that there's no excess current drawn, which there wasn't, and the transformer was not running hot, and it was providing the right secondary voltages. So then the next thing to do is to check to understand, why is there excess current. The most logical place to start are the output transistors. So when you drop the multimeter on there, what I was able to quickly identify was that the left channel TIP or TIP 3055 transistors were short circuit, so hence the reason for the failure. So to undertake this work, quite straightforward, you just need an Allen key just to remove the front control knobs. And then when you flip the amplifier over, you only have 3 screws which just hold that front bezel in place. And once you remove it, then you have a number of fixing screws through the circuit board to the grounding points on the chassis, and then you're able then to lift up the main amp board. So here, first thing was to replace the failed TIP 3055s. Now, for people who have listened to these audio blogs for repairs before, you'll often hear me referring back to genuine originals, and that is the case here. You can buy TIP 3055s, modern versions, but they don't work in an amplifier like this. So what you will see in the video is that I am installing brand new original TIP 3055s, and once they're installed in there, I know that when I come to bias up the amplifier, which I'll cover in a little while, and also during test and then normal operation, I'm going to have stability because the characteristics of those devices match the originals and how the circuit was then designed. What I also did as well, and you can see this towards the latter part of the video where I show the different components that have been removed, I also changed the insulating washers between the back of the power or the output transistors and the heatsink. What you could find is that the through hole in some cases was much larger than it should have been, although on the power output transistors you have some degree of insulation on the tab when you pass through the insulation washer, but there was a risk that maybe it could touch, so just replaced all of those then. What you also see in the video are the emitter resistors. Now 2 of the emitter resistors, when they were checked on the failed left channel, had gone slightly high. There's quite a considerable difference between the 2. So here I just replaced with brand new Vichy type. And then one on the right channel, the enamel coating for some reason had sort of broken away. So just to keep uniformity and then to ensure that the same emitter resistors are used on both channels, I just replace all 4 of those. And then the other thing that the video is showing, and this is a little bit of sort of peculiarity for this amp, that when you looked onto the solder side, in the area of the failed output channel, you have a number of small electrolytic capacitors, and there were a number of solder pads which had broken away from the board. So one lead was connected and one lead wasn't. So again, as I've said many times before, just use some link wire, so scrape off the covering on the copper track, and then you can then use a link wire then to make a good mechanical strength and then reconnect. So there's probably about 3 or 4 of these. And then I'm also checking the circuit board as well for dry joints, and there was a few dry joints on the user controls. For example, the tone stroke treble, stroke treble bass controls and balance controls. So those are all flowed. And then as I'm checking through, and I show this in the video, there is a burnt out track, and where this burnt out track came from or comes from was the secondary of the transformer through to the 4 diodes which are used for rectification, and we call that a full wave bridge rectifier. So on both half cycles it is able then to rectify from both sides the transformer, both the positive and then the negative supplies. So because one side was broken, feeding the one side of the bridge, then of course we would have half wave. So this, whether or not this issue occurred when the output transistors failed, which would be highly unlikely, or maybe there was something else which happened previous to that, but yeah, it was blown, the track was blown. So rather than just use non-insulated link wire, what I've done here is I just used some insulated link wire, the appropriate current rating, because you kind of at the on the secondary side of the power supply, and just to make that repair good. So once that was then done, my sort of attention then was paid to the input power fuse. Now the input power fuse is covered by like a rubberized holder, and this fuse had been in there no doubt from when the amp was manufactured. Now for anybody who's worked in the service industry for electronics or has repaired older equipment, sometimes what happens is that you see particular faults which are purely age related. So even if you study electronics and you do this at some form of institution, or you're learning it yourself, what they'll talk about is the operation of electronic components, for example a fuse. But what they are not going to provide, of course, is what happens to a fuse if it's been in the same circuit for 30 or 40 years. What I'm referring to here is when you remove the fuse and you tested it with your multimeter, the anti-surge fuse or surge protection fuse had started to go resistive and unstable. And I've seen this in the repairing so much equipment over the years. And you first look and say, well, it didn't make any sense. But this is what has happened. Maybe the chemical composition of the fuse wire, something has happened. So when you put your meter on here, this was sort of fluctuating, almost like to sort of 35 ohms or thereabout, and it's unstable. So as you're measuring the resistance, it's sort of floating around all over the shop. So replace that fuse straight away, and then you know that there's going to be no sort of fluctuation then on the power input stage for the amplifier. And then once that was all done, you can then move and again make sure that you do additional testing in the output stages. Okay, I don't want to sort of convey to you that all you do is you find two output transistors which are shorted, and then you put two new ones in and then put the power back on. You don't. You replace the failed components that you've identified, but before you even consider powering up the amplifier to adjust the bias, do not do that until you've made extensive checks on the resistors in the circuit. You're also going to check the driver stages of the amplifier, so you really need to make sure that there's no other underlying issues with any components in the amp, which could be sort of sitting there, and then you come to power it up and then it leads then to another failure. So once all that was done, the next part then is to power up the amplifier by the dim bulb tester. And the bulb did not light brightly at all, because we know the output transistors were replaced. So you're confident that you can move to the next phase, which is just to maybe just do an initial test, all right, before I've even biased the amplifier up. So I can just connect my headphones there and then just run some audio through, and sure enough, everything was working very, very well, good audio quality. So depower the amplifier, and then what I'm doing then is I'm following the instructions in the service manual, and setting up the bias on this amplifier is a little bit unusual when I compare that to other integrated amplifiers. Normally you have test connections and the output stage, and more commonly you're measuring across the emitter resistors, because the current from the current output stage of the finals then is passing through the emitter resistors, and you're measuring the voltage drop across normally these 0.22 ohm emitter resistors, which is shown also in this repair tutorial. But that is not the procedure for the A60. What you have to do is you remove the two protection fuses, which are these fast flow 3.15 amp fuses, and then what you put in there are 5 watt 15 ohm resistors, and I show this. So you connect those in place of the fuses, and then you then apply power to the amplifier. But before you do that, you have two bias potentiometers, one for the left channel and then one for the right. So what you need to do then is you need to turn fully anti-clockwise RV2 and fully anti-clockwise RV102. And this is common again for these series of amplifiers. They use the same reference number, for example 1, 2, 3, 4 for the left channel to identify different components. But when it's the right channel, it's the same circuit fundamentally, but they just increment it by 100. So when they say RV102, they're referring to the right channel. So once those two presets or trimmers are then set anti-clockwise, you power up the amplifier, and on the initial power up, when you put your meter across the positive 15 ohm resistor in the fuse holder, you should read approximately 0.5 to 0.6 volts. And sure enough, under initial test phase, it was sort of coming up just about 0.2 or thereabouts. Now, you don't have to wait for the amplifier to warm up to do the first adjustment. So what you need to do then is quite quickly keep your eyes on the meter, and then you have to increase then RV2. And what you're increasing it by is 0.2 volts. So you're watching the meter, and then it should increase by about 0.2 or 200 millivolts. And once you see that, you then have to move to RV102. And then you increase RV102 by again 0.2 volts on the meter or 200 millivolts. Once that is done, you have effectively set the bias, and you're just going to look at to see, what's happening there. And what you should see, probably after 2 or 3 minutes, the current flowing through the 15 ohm resistor will start to stabilize, and you should be reading approximately 1.4 to 1.6 volts. If you don't read that and maybe it's still below 1.2 volts, what you can do then is just go to RV2 and then just make a very slight adjustment. So you're bringing it up, and maybe you bring it up by probably 40 or 50 millivolts. And then what you can then do is you can do the same then for RV102, but just take your time to just sort of move the trimmer very, very quickly, and you'll get it to the correct position. Now, as the amplifier is running, you need to ensure that there are no speakers connected when you do this, nor your headphones, and your volume control then is at minimum. And you can leave the amplifier running 10 or 15 minutes, and it should remain stable, but as I said, between 1.4 to 1.6 volts as you measure across the resistor. What you must observe is that if you are setting the bias current for the 2 channels, the amount of current flowing through the resistor cannot exceed this 1.6 volt threshold, right? So it can go slightly higher, but your critical cutoff number is 2 volts. Under no circumstances can it go to 2 volts, right? So as long as it's between 1.4 and 1.6, then all is good. And then the other thing with this amplifier was really just to clean the user controls. So what I'm cleaning here are the balance, volume control, and then your bass, and then treble. And then you also have the push button switches for the filter, the mono, your moving magnet input, and then your other line input. So you'll see that there's small holes in the top, and you can spray directly into there some deoxit. And because they're push buttons, you can just operate them multiple times, and you should get noise-free operation. And then the same with your user controls as well, your potentiometers. What I tend to do is sometimes I'll just put the amplifier on a vertical plane, and then I'll just put a bit of sort of kitchen roll just on the little sort of cutout port, and then I'll spray the deoxit in directly, and then rotate many times, and then just take up any excess then from the bottom there. So really that sort of brings us to the end of this tutorial. So like always, hopefully you've sort of you've learned something. Just one other point just before we sort of close off, because I'll show this in the video. What I've done is I've taken an extract from the service manual. What I show here is the A60 left channel, and this is both the sort of the driver stage and then the output stages. And I'm just making reference, so you can see RV2 at the left hand side just towards the bottom of the circuit diagram to indicate that this is the trimmer that you would then set for your bias. And then what you can see also are the emitter resistors, which are 0R22 or 0.22 ohms. And then I'm also indicating then the tip 3055 output transistors as well. What's sort of interesting with this is because it's a very old amplifier, sort of 1978, when you look at this circuit diagram, it's almost as if it's been drawn by hand. But what you do get is quite a detailed description within the service manual, which is very good. This is, like, to me, a bit like old school, where the engineers who built the amplifiers, or sorry, who designed the amplifiers, would put a lot of service information in there, and then the service information within the manual also covers upgrades as well, which have taken place as they've identified maybe some field issues with the original design, and then made sort of recommendations, changed parts of the circuit. And interestingly, the service manual also describes some kits that are available that you could have bought back then. So really sort of old school. So once this amplifier was restored back to normal operation, you know, the owner will get many years of listening pleasure, and it's always a high quality sound that you get. So thank you very much, and I appreciate you listening to this audio repair overview. If you have any questions, and I always say this, by all means you can email audio amplifier servicing at aol.com at any time, and I'll be more than happy to come back and then advise you or provide for you any sort of repair information. And we've repaired a lot of amplifiers in this way remotely, and if you need any help or support, you know, just let me know. All right, so thanks very much. Until the next time, cheers, bye bye.